this would be 2 and 2. Okay, so 2 2. So this logic, if we can put it in the form of some generalized manner. Okay, so even that can be done. Okay, yes, even that can be done. So how that can be done? For example, if I take I and j, so I is 0, j is 0, and that needs to be incremented. That needs to be incremented up to 0 1 2. And so there, let's put it into a logic. Okay, here, so I is equal to 0 and j is equal to 0. Okay, but we'll have to write it, I think, this way only. Yeah, 0 0 0 1 0 2 1 0. Okay, so if yeah, I is 0 all the time, and this is increasing 0 1 2. I is 1 all the time, increasing 2 all the time. Second one is increasing. Okay, so yes, so let me not formulate it. It'll take few more minutes otherwise. So I'm just formulating it this way. So this is basically for the first you can say first approach, that is row wise. Second will be column wise. Okay, so column wise, how will it be? That this is 0 0 1 0 and 2 0. Okay, so column wise, 0 0, then this has to be 1 0, and this has to be 2 0. Okay, so the first column, then this is 0 1, this is 1 1, this is 2 1. Okay, so next would be 0 1. Okay, 0 1, and then I'm sorry, control Z, Z. Yeah, so here, so 0 1. Okay, after that this should be 1 and 1, and this should be 2 1. So 2 and 1. Okay, and then this is done. Column wise also done. Okay, so column wise done. So we have 1 2 3 4 5, 6 should have been done. So okay, so 2 is also there. Yeah, 2 we have not done. So this will be 2 0, sorry, 0 2, 0 2, and this is 1 2, and this is 2 2, 2 2. Column wise also done. Okay, now diagonal. So two diagonals we have. Two diagonals means 0 0, then 1 1, 1 and 1. Okay, and then we can have 2 and 2. So 2 and 2, that's it. And then we can have second one as um, this is 0 and 2. So 0 2 we should have. And then the next one is this one is 0 to 1 and 1. Okay, so 1 and 1, and the third would be 2 and 0, 2 and 0. So these many conditions we'll require, rest we don't require, so I'm just removing rest of them. Okay, I've removed them. Okay, so this much condition we require. If this, okay, so if it is equal to this, then we can return, okay, return a string player, player x is for 1, player 1 is winner. Okay, and then what we can do, then we can have here elif elif. Okay, elif, and in elif we can put again the same thing. Okay, yeah, so in elif we can put the same thing from here till this part. Okay, just by replacing all the x with o. Okay, so whenever we have o, we can just replace it by o. So this is also the logic almost completed for the tic-tac-toe. Okay, I could have, yeah, this as well. It's done. Okay, so here player 2 is the winner. Okay, and at the end what I can do, I can just write yeah, at the end I can write ELSC else, and here, yeah, yeah, I'm doing a mistake, so Control X, yeah.
Court progress.
Okay. So hope you understood. So I was doing that mistake. This needs to be, so for else also, yeah. So here we need to have a colon and enter this statement and enter, and else, yeah. So here we can have ing playing. Okay, keep playing. Slash So this is a function now we have. Okay, so this function somewhere something invalid. Okay, yeah. So one mistake I have done. Let me just correct it. Where is the notepad plus plus? Yeah, it is here. I need to, yeah. So yeah, it has to be double equal to. Okay, fine.
दरवाजे लावा दे.
Okay, so a function is also there now. I have once again, I have the board set. Okay, I have the board set, and then I have a logic here that how the player can insert the values, and I have a function for identifying the winner. Okay, so I should create this also. I should put this also into a function. Okay, that which I need to provide a logic now. The flow would be, let me decide the flow. So here what we can do, the first step we can ask. Step one could be mm, markdown. Flow. So first we will display. Okay, so display the board. Okay, so first we'll display the board. Second, we will ask player one, okay, to play. Okay, so player one will okay, to take a move. Okay, take an action, or we can say, okay, and then we will, after player one is taking an action, okay, after each player is taking an action, we can check the winner function. Okay, check the winner function, and then player 2 uh, to take an action. So player 2 will take an action, and again then check check the winner function. So this is how we can go. Okay, so player 1 taking an action, then check the winner function. Player 2 taking an action and check the winner function. Okay, or in this case, here, if player 1 is winner, break. Okay, break the game. And similarly, if player 2 is winner, then again break the game. Okay, so this is how we can go. Okay, this can be the flow. Now in this case, yes, in this case, displaying the board, we have the code for displaying the board, there is no problem. Okay, and yes, so this is initialized only for the one time, and after that we are always updating it. So this update, okay, so this is a move, this is a move, and yeah, so we need to determine that how the move is going to take place. So this, let me put a tab over here, and this, let me put it into def def move. This is a move. Okay, and yes, enter. Hmm. Okay, so we can check that which player is playing. Okay, so which player is playing, that we can check, and that can be passed here. Okay, that can be passed here as uh, yes, as v. Okay, v means value. Okay, and instead of x we can put here v. Okay, so just a second, control z. Yeah, so instead of so here we can check, we can put v only. So yeah, if it is player one, so here we can initialize if v is equal to uh, player player one. Okay, then what to do? We can just mention here. Then we can have a local variable. Here let's have a local variable as value value. Okay, value is equal to, it's empty. Okay, empty string. So we can have value is equal to uh, yeah. So if player one value is equal to x, and then yes, here else value is equal to O. Fine. So here we will put value. Yeah. So instead of putting x, we will define it as, we'll put values here. So instead of hard coded, we have now given the dynamic values over here. Yeah. So this way. Okay, it's done. Let me be a little more faster now. Okay. So this function we have created. Okay. So yeah, this function is, let me write also. So here, what is v? V is the PLA player. Okay, one, or PLA player two. So we have to pass v as player one or player two. That is something we have to pass. Okay, and accordingly, this function is going to put. Okay, that yes, accordingly this is going to put there. Winner function we have taken, and we have a display board already ready here. Okay, yes, and this is going to initialize the display board. This is just for test purpose, nothing, no changes it is going to do. And this is a function, again nothing it will do until unless we'll call it. And this is a winner function. Okay, so now we can have while. Okay, yes, so we need to have some variable. Okay, and that variable we can create here. So while done is equal to false, false. Okay, false, false. So while not done. Okay, so while not done, what we need to do? So we need to first of all, here only we will display. So print, yeah, we can display inside only. Why to display outside? Yeah, inside we can display. So print board. So we'll print the board, and we will call the function move function. Okay, but when we are calling the move function, now here we need to define. Okay, um, once the move function needs to be called by player 1, and then the move function needs to be called by player 2. So this logic only we need to define. So first we can write it as mm, mm, so we are passing v, right? So v is equal to PLA player 1. Okay, PLA player 1, and move v, and then we need to check this function. Okay, winner. So we'll call winner function over here. Winner, do we need to pass anything to winner? No, we need not to pass anything to winner. And yes, we need not to call pass anything to winner. And then after that we have to do v is equal to, then it will become player 2. Okay, so player 2, and then again we need to call the winner function. Okay, so let's run this. Okay, and yes, we have to make done as we have to make done as true. So when we can make done as true, we can make done as true here. Okay, so here I think yes, we can take it as global do you any done is equal to true. Okay, and in this case also we will make global do you any done is equal to true. Okay, so yes, let's yeah, just a second. So enter done equal to true, and global done equal to true. Okay, we already have, okay, we have not wait, so this needs to be, somewhere here. Done is assigned before global declaration. Now we have defined it, right? Yeah, so global. Okay, global done. Okay, and done equal to false. Name done is assigned before the global declaration, and this is line number 28. Okay, let me take it as regular. Let me just take it as control Z Z Z Z. Okay, done. I'm taking it as regular and control Z, done equal to false, and return. Mm -mm -hmm. I'm just yes, so done equal to false, and while not done, so we are calling yes. So in the function, let's just make it as, yeah, so done is equal to true, and here also it is just make done is equal to true. Okay, fine. So once again, let's clear out everything and just run it, and let's see if it works. If there is something, we can modify it. Okay, so we have the board, and as expected, yes, board is like that only. Then we have this function, and then here. Okay, so let's try to play here. Okay, so enter the position. So I'm putting the position as 0. Okay, and so you can see that it's saying keep playing. Okay, and after that this is enter the position. I should display the name of the player also. Okay, so let me just put the positions first, and then I will display the name. Okay, so I'm putting position 2 and position 3, 4, 5, 6, 7, 8, 9. Okay, and okay, so here you can see that done part is not yet working. Okay, so that done part is not yet working. So I need to break this. I'm stopping this here. Okay, breaking this down. Okay, I have that done. The first thing is this player. Okay, so let me take it here. Yes, I have taken it here, and print board, and it is okay. It is ask. No, it was, oh, it was all right. Yeah, it was all right. So here when I'm printing, where I'm displaying, yes, enter the position. So here I can print the value, input the value. Okay, so here I can write print which player is this. So V is PLAYING. Okay, playing. You can just have like this. Okay, currently V is playing. Okay, this way we can have, and yeah, so this done is equal to true, and return player is winner. Okay, this is something. It is player 1 is winner, 2 is winner. Yeah, so let me return two things. Okay, let me return two things here. So this I can just print. Okay, this I can print, and I can print here. I can do return done. Okay, so I can print it, and I can return the done part. Okay, so here also, instead of return, I can print it, and I can return here. Okay, return return done. Okay, so now it should work. So while, so here done is equal to move. No, wrong. Winner is equal to, okay, so done is equal to winner, and again do I need done is equal to winner. Okay, so once again clear output. So what I'm doing, I'm just updating the value of done here. Okay, so I'm just updating the value of done here, so whether done will be true or false. So whenever winner function is going to execute it, then if this is going to be true, then done will become true. If else, if this is going to be true, done is going to be true. Otherwise it will keep on saying keep playing. Okay, so now let us run it once again, and expecting that this way it will be. And lastly we can print here. Okay, print game over. Okay, so game over. Okay, fine. So let me execute whole thing once again, run all. Okay, yeah, so it is executing everything. It has executed, and we can see the board is in front of us. And let us enter the position. Okay, so now I'm putting the position as 0, let's say. So we have yeah, so currently player 1 is playing. Okay, one more mistake if you have noticed. So we have to do move and then winner. Then we have to perform move once again. So move once again with V. Okay. So yeah, it was a mistake if you noticed. Okay, we did not give chance to player 2. Okay, so yeah, once again restart and run all. Okay, yes. So just ignore the print part. So it is printing this first and that second, so just ignore that as of now. So I'm filling at value at position 1. So yes, now player 2 is playing, so we can observe X is here, right? And player 2 is at location 8. So you can see location 8 has become O now. And now player 1, okay, so player 1 is putting 0 now. And so you can see it is XX, and player 2 is putting at let's say position 5 now. And you can see that this is OO and this is XX, so this is OO and XX. And obviously player 1 should put position this. And here, so player 1 is winner. Okay, so player 1 is winner, but it is still continuing, so this should not continue. So lastly what I will do, lastly I will just write after return. Okay, I will say yes. So I should break the program here. Okay, so yeah, it did not break. So if done is true, okay, so here I can write if done is equal to true true, then break. Okay, fine. So once again I'm playing the game. And okay, it's I need to reinitialize everything. Yeah, so clear outputs. So I hope you got it. So final time we'll run this, and I'll upload this. You can just execute and try to have fun with this program. Yeah, so yes, it is. Now I'll put the position. I'll just try to check. Okay, yeah, so player 1 is playing. And yeah, it's X here. And player 2 is playing now. Player 2 will put 6 here. And now you can see at the position 6 it is O. Player 1 is playing, put the position as 1. And player 2 is playing, and it will put a position as 2. Okay, and so now player 1 cannot win. Now player 1 needs to put somewhere, let's say puts at 8. So okay, so you can see it is X. Player 2, it will put 4 and enter, and yes, you can see player 2 is winner and game over. Okay, so this was a simple demonstration of a simple program where simple problem statement where we try to define the problem statement first. Okay, and while defining the problem statement, then we try to identify what will be the state space, and we try to identify how many agents are there. Two agents are there, and then we tried that what sort of actions they can take. While taking the actions, what sort of strategy or policy is there, like what are the rules. Okay, so here you see I have not defined the rules. Okay, I have not defined the rules. If I will try to put the same values, it will actually put. Okay, so because that will consume some more time, so that you can take it as an assignment, you can apply the rules into it. And if a value is already, like, I'll tell you the logic. Okay, what approach immediately or simplest approach you can do. You may store those values, whatever values are being put here. You may store these values into a list, and you can always check if the player is inserting any value. If it is present in the list, then you can tell the player that insert a valid value. The position is already occupied. Okay, so simply you can use a list, and with the help of a list you can perform this. Okay, so yes, I hope you are able to understand this. Even non-programmers will be able to understand, because the logic is not so complex. It's very simple. Any quick like comments or discussions, or any questions are most welcome. How to deploy model or game. Please do any small code as example. Okay, so you mean to say any machine learning model you want, how to deploy that, if I'm not wrong. So I'll show you that as well. I'll show you that as well. Okay, so sure, we'll share feedback at the end of the session. Okay, any other feedback we have? Okay. Okay, yes, so I'll show that as well. Yeah, so let's have okay, let me show you that first, and then we'll move ahead. So let me take some example. I already have some created examples here. So let's say missing values, functions, simple linear regression, chatbot, basic syntax applications. Okay, let me create something. Let me create something of my own. Okay, so yesterday we had seen an example. Yeah. So yesterday we had taken an example, not yesterday, day before yesterday, in Excel. There was one algorithm that was KNN algorithm, K nearest neighbor algorithm. So let me just try to execute that only. Okay, so K nearest algorithm. Yes, so let me create one Python file. Hmm. And KNN on iris DASET dataset. So let me introduce you iris dataset, and this is a very popular dataset. And once again, like we do hello world programming, it is exactly like that. Okay, so whenever we start data analysis, or we try to perform EDA, or we try to perform in fact machine learning, or any program in AI. So this is the data set which is being first explored. Okay, so this is very interesting data set, and let me tell you what is iris, and based upon that we will see that how we can work with it. Hmm. So iris. Okay, so iris is a flower, and you can see the images. So it's a beautiful flower here, you can see. And this flower has got multiple species. Here also we can see that this is having, if you see the sepal, okay, these are the petals. If you see the petal length and petal width, okay, and let's try to compare it with some other type. uh, yes, so yeah, here I think with this it may not be very much easy to understand. Yes, so this one also, if you see, it has got little wider sepal lengths. Okay, this has little narrower. So it has got species, different types of species, and where we try to calculate the size of the petals and sepals, okay, and identifying the width and length of the petals and sepals, we try to classify them. Okay, we try to classify them. Now, there are two things. One is basically that if we have already given that this species is of this kind, let's say they have three kinds. Let me show you the data, and with the help of that data we'll be able to understand. So hmm, let me have iris iris dataset UCI. Yes. So here you will find a lot of data sets. Okay, all the data sets you can find here. Here we will see, yes, dataset folder. Okay, so here if we see the attribute information is given, like what all attribute do we have in this particular in this particular data set. So here we have sepal length, we have sepal width, we have petal length, and we have petal width. So four columns we have: sepal length, sepal width, petal length, and petal width. And fifth column we have, and that column is your that the last column is your class, that which particular class does it belong to. Okay, so this belongs to setosa or versicolor or virginica. Three classes are there. So let me show iris.data here. Okay, I think it will get downloaded, no worries. So let it get downloaded and let me open it in. So open, yeah, so let me open it. Yeah, I can understand. So let me click here, show in folder. So let me just open it in notepad. Okay, so let me just open it in notepad. Yeah, so look at this. So here you can see we have sepal length, sepal width, petal length, and petal width, and then we have the class. So we have 150 records, total 150 records. So 50 records, first 50 records, if you will see, so till this place we have setosa species, another 50 records we have versicolor species, and another 50 records we have virginica species. So three species are there of the same flower. Okay, and they are differing a little bit in their petal length and width and sepal length and width. So this is basically a data set very famously popularly used. Now let me ask you that uh, in case of supervised learning, what we will call this as. Okay, you can see this last column. So quick responses in the chat, or maybe verbally you can explain. So in case of supervised approach, what will we call this last column as? Quick responses in the chat. Supervised approach, because we had seen supervised approach, I think in day one or on day two, that supervised approach has got exactly, so labels. So we will call them as labels. Okay, so they are classes, they are labels. And if I want to perform KNN, so KNN is not a supervised algorithm. It is a unsupervised algorithm. So KNN does not require this, or basically you can say we don't have the label in the data if we are performing some unsupervised algorithm. So I believe this is very much simple and logical to understand, that for practice purpose we just remove this last column, so that we are left out with these only, and with these only we work. Okay, with these only we work. Okay, so let us now move ahead and work with it. Okay, so let me go back to my notebook, and here we can start. So yes, so normally we may require NumPy library. So I will just do import NumPy as NP. We may require if we want some graphs. Okay, so if we want some graphs, then we require the matplotlib library. So I will do matplot matplotlib library lib. Okay, dot pyplot as plt, and we may require another library is there. Okay, Seaborn. So we'll see whether to use it or not as SNS, and let's have yeah. So these are optional, not compulsory. Okay, so I'm just putting a let me just put a comment and here. So the actual library we require is from sklearn. So sklearn is the library from sklearn import. So here we require k nearest neighbor. So this comes under neighbors. Okay. So NEIGHBORS neighbors. Okay. And we have sample data sets also. So I'm not going to upload data sets. So we have data sets. I'll be taking out data sets from here only. So we have imported certain libraries, of which we just need from sklearn import neighbors and data sets. Okay, so data sets and neighbors we require. Now, in case of k nearest neighbor, okay, in case of this algorithm, we need to tell that what will be the number of neighbors. Okay, so we are not getting much into that. So I will just plan that the number of neighbors. So I'll just plan n underscore neighbors, and we can plan it any value. So 150 we have, so we can plan it with, let's say, 20 nearest neighbor. We will consider 20 nearest neighbor. Okay, and now we need to import the dataset. So we have just considered neighbors. I hope you remember in KNN algorithm, if there is a new element, it will try to see that which are those 20 neighbors with whom I am very much similar to. So if 20 neighbors are of Setosa type, so we will call the new element also you are also Setosa type. If out of those 20, 10 are Setosa, 5 are versicolor, and 5 are virginica, so we will tell that you are more similar to Setosa, so you are in Setosa only. I hope you are getting. So the new entity, new flower species, will be compared to the existing flowers, but how many? The top 20, the top 20 matching ones. So out of those matching ones, we will see that where does it sorry, yeah, so which cluster does it fall into? Okay, so here we are not aware of Setosa and those things, so I'm sorry I used those words. We cannot use those words. Okay, so it will first create groups, and yeah, just a second. So okay, let me I got little jumbled up. I have used neighbors here. So this is supervised approach. Let me just clear you. So just understand. Yeah, I was explaining very correct. This is supervised approach because I have just typed neighbors. So yeah, I should have taken clusters actually. Okay, so I have typed neighbors, so we can go with this also. So what I was explaining, it will check for the 20 nearest or 20 matching species, and if those 20 are falling under, the majority of those 20 are falling under one category, that would be the category of the species which is a new species. Okay, this is how it is happening. Okay, so let's move ahead and try to import the data set. So iris is the data set. Iris is equal to, we can get it from datasets. Datasets dot we have function as load. So here you can see if I'm typing load, so here we have multiple data sets. You can see Boston is there, breast cancer is there, diabetes. Okay, so here we have iris also. So I'm loading iris data set. So this is how I have got the iris data set. Okay, just for display purpose, let me just display the iris data set. So this is how the data set looks like. Okay, and it gives us beautifully because it is in the dictionary format, and this is the data. It is saying this is the data you have inside the dictionary in the form of an array. The data is present, and after the data is over, look at the, please look at these, if you can look at these 5.1, 3.5, 1.4, 1.2. So these are nothing but the parameters which we discussed here. So here you can see sepal length, sepal width, petal length, petal width. Okay, if you go down, there also description is given. Okay, what is this? If you just scroll down, you will see that the description is given. So here it is given that target names, first is setosa, then versicolor, then virginica. Okay, and it has given the output here 000, 111, 222. Don't get confused. What is this? I'll tell you. So this is iris setosa. So it is difficult to, it is not recommended to handle the data in the form of string. So better to give setosa as 0, and after setosa better to give versicolor as 1 number, and better to give virginica as 2 numbers. So this is what is being done. So 0, all the first 50 are setosa, and the next 50 are versicolor, and the next 50 are virginica. So this is what uh, has been put as a data over here. Okay, and then the rest of the description is given. You can go and read it. Okay, so the data we have got the data. Now what I will do, I will split the data into two variables. Okay, so normally the input variable, okay, it is called as x. So x is equal to, okay, normally we denote it as capital X. So input is equal to iris, okay, dot data. So iris dot data will bring the input to x. So what we can do, print this x, and so here you can see whole of the data has come here. Okay, so the data has come here, only the data part. Similar way, the output is represented as y. So output, or you can say labels. Okay, so labels are represented as y. So y, and normally small y, and you can guess now. So iris dot that variable name is target. Okay, so iris dot target, and we can just print y. So you can see here the target is given. Okay, so we have done split, okay, of input and of output. So we have the data, and we have the data into two different variables now. Now we need to see that in this case, do we need to put all of them? Okay, or we need to put few of them? This is something we need to decide. Once again, I'm saying, in the input, do we need to consider sepal length and width only, or petal length and width only, or we need to consider all? So as of now, let's plan to consider, okay, let's only two dimensions. Okay, so what we will do, we will take only two dimensions, and for that I can write colon, that from the starting row to end row, and the first two I will take, first two. Okay, so first two are your sepal length and sepal width, sepal length and sepal width. Okay, so only first two I'm taking, and the next two I'm just eliminating. So you can see that I have taken only first two. Okay, so this much I have taken. Y is as it is. Now let us move ahead and try to apply the algorithm. Okay, so how to apply the algorithm? Before applying the algorithm, we have two steps. One step is known as train step, and another step is known as test step. Okay, so for train step, we need to split the data. Okay, so split the data. Why to split the data? Because for new input, okay, so for new input we'll have to create some new data. So instead of that, what we normally do, we split this data. Okay, so for that, again, from sklearn, okay, import train test split. So there is a train test split. If I'm not wrong, it is coming from sklearn only. So it comes from sklearn dot, yes, cluster. We have data sets from metrics. Let me just check model selection. model selection, import, yeah, train test split. Yes, so from sklearn.model selection, we can have this function. I can manually also split the data, but I'm using this function here, and I will do it like this. This train test split will help me with x and x train and x I'm writing here, y train and y I'm writing here. We'll just test and then we'll move. So train test split, and here we need to put the data. Okay, the data we have here is x and y, and we need to mention here the uh, this thing size. Okay, just a second. So let me just execute this and go back and okay. So here we need to mention test size. That test size we can give 20 or 30%. Hmm. So test size we'll give. Okay, so the variable name is test size. Test size. Test size would be test can be small. Okay, so we can put 0.3. Okay, 30%, and execute. Okay, so now we need to just check what is there in x train and xy. Okay, so x train, so it is having mm, okay, so these many records, fine. And what is there in x? Yeah, x is having only few records. So x train is having larger records, x is having few records, and y train is having yeah, so larger records, and only y is having few records. Correct. So now this we will just name it as test, and we'll just rename it as test. Okay. So we have x train. So this is how we have now. Okay. Let me just uh, restart and clear, because we already had y variables earlier also. So I don't want to make any sort of confusions. So yes, once again, let me just execute. Okay, so we have the data available here. Okay, x train and x test, y train and y test. Now what we need to do next is we need to go for hmm, yes. So we need to go for uh, training part. Okay, so for training part we have let's say knn model we are creating. Knn is equal to neighbors. Okay, neighbors dot, so here we have k neighbors classifier. You can see we have k neighbors classifier, this we have taken, and this expects okay number of neighbors. So number of neighbors we can put here. So n neighbors is equal to, we have already given there, I'll manually put okay 20. So number of neighbors I have put 20. So this is known as we have just created a model. Okay, we have, so here created a KNN, K nearest neighbor model. Now after creating the model, what we need to do? We need to train the model. Okay, so for training the model, what I will do here, train the model. So for training the model, I will just do knn dot fit. There is a fit function, and inside fit function here you can see we need to give x and y. Which are these x and y? We need to give x and y, which are the training ones. So x underscore train, this we have to give, and y underscore train, this we have to give. So we have trained. Okay, the model is trained now, and after that we have to make the predictions. Okay, so for prediction I will create a ypred variable is equal to, so knn dot predict. So in predict I will put now x test I will have to put. So ypred has got the so yeah, so let me take this here. Okay, so this is the testing part we have done, and here I can print y underscore pred. Okay, yes, so here you can see that these are the predictions, but I would also like to show you print and y underscore test. These are the actual values. Okay, so these are the predictions and these are the actual values. Now don't get confused here. Let me tell you that here wherever you are able to see this 2 2, okay, so that is basically equivalent to 1 here. Okay, how is it so? Because this is just an understanding you can see here. So wherever two twos are there, they are mostly ones here. Okay, so zeros are zeros, but twos are ones and ones are twos. It is like that. Okay, in this also we need not to get much into, because we have got metrics over here. So let me just import some metrics to check the classification report or to check the accuracy. Okay, so let me have some metrics to check the accuracy. Yes, so yeah, hope you have got it. Okay, so what we are able to see here, we are able to see that this is the prediction, and this one is the yes, this one is the actual output. So let me have from sklearn dot metrics. From sklearn dot metrics import classification report. Okay, so just a second. So yes, here. Yeah, so for classification report for iris. Yeah, so here we can just have uh, from metrics only we can do. Yes, correct. Let me first have let's just import sklearn and dot metrics. Okay, so from metrics only we can have all the parameters. Yes, so metrics dot accuracies report we can have. For this we will have accuracy score. So metrics dot accuracy score. Type okay, accuracy and underscore score score. And here, yeah, so here I can put in the accuracy. One is I have the test y test, and one is I have the y pred. So I can put these two things, and name matrix is not defined. Okay, I'm sorry. Yeah, so as metrics metrics. Okay, so here you can see that the accuracy is 75%. Okay, 75% is the accuracy. A similar way we can have print, and we can have a confusion matrix here. So for that, I can have metrics dot confusion matrix, and for confusion matrix also I need to put y test, and I need to have y spread. Okay, so this is the confusion matrix, and how to interpret this confusion matrix? You can interpret by, yes. So let me show you that so that it becomes clear. Yeah, that is flour. Yes, so here CONFU confusion matrix. Yes. Yeah, so let me show you here. Yes, so this is the confusion matrix, and here you will get as a column the predictions, and as a row you will get the actual. Okay, and it tells us about true positives and false negatives. It tells us about that. So here if you see, true positives are, they are actually true and predicted as true. So let me just take you there and let me just interpret. So here if you see, so the first, here I don't have a mechanism to mark down. Let me take it to paint. Okay, so here you can see what we have done. Let me take it to paint and print it. Yes, so this first one is, if you see, this is setosa. Okay, this one is VRSI versicolor, and this one is virginica. Okay, and similar way here also, this is setosa. Second one is uh, VS versicolor. Third one is VG virginica. Okay, and now you can see that. Let me just highlight them. So here, this 18 value, the first value 18, you can see setosa, all the setosas are identified as setosas. Okay, but if you see, only 6 versicolor are identified as versicolor, but 10 of the versicolors, okay, look at this, 10 of the versicolors are wrongly identified and they are identified as virginica. Okay, here in case of virginica, one virginica has been identified as versicolor and 10 virginicas are classified as virginicas. I hope you are getting this. Okay, so this is basically the confusion matrix. It tells us that which are correctly classified as they actually are, and which are wrongly classified, and how many of them. So the poorest classification, if we see, we are getting for the versicolor. That means most of the versicolor sepal length and sepal width, they are actually similar to virginica. Okay, now let me just do a little tweak. Okay, let me just do a little tweak, and what I will do, in the same, I will keep everything same, but I will just make a change in the beginning here. Okay, so instead of taking the first two columns, what I will take last two columns. Okay, 0 1 2 and 3. Okay, so last two columns I will take. Okay, let me just execute. So you can see that the values are changed here. Now I will execute the whole. Okay, so restart and run. So I'm running the whole. Hope you got understood now. So I'm taking the last two parameters instead of the first two parameters, that is petal length and petal width. And here you can see the accuracy is 93%, and the earlier accuracy was 75%. And this also, let me take it there. Okay, the confusion matrix, let me take it to the paint, and here let us put it. So you can see here that setosas, now let us look at the setosas. All the setosas are classified as setosas, and all the these things versicolars, so 13 versicolars are classified as versicolars, only 2 are wrongly classified, and all the virginicas are classified as virginicas, only one is wrongly classified. So you can see the error out of all the records is 1 plus 2 3. 3 is the error. Okay, so therefore it is saying us that it is 93.33% accurate. So I hope this example satisfies your question. So this is how we can import some machine learning models, and then we can have the data divided into training and test part. Because we are doing an experiment, therefore we are doing this in real time. We need not to do this. We will keep on receiving the new data sets, and we will keep on revising the model also. In case of real time, we will keep on training the model like on a regular basis, so that model learns on regular basis. Okay, so that is something we will keep on doing in real time. And then we initialize the model here, we train it. After training it, then we make predictions. Okay, so this is how. So I hope this solves the query. Can I get quick confirmation on this? Yeah. See more. Any comment apart from this? Okay, so are we good to go ahead? Can I get a quick confirmation on the chat box? Yeah, are we good to go ahead? Okay, how to choose best algorithm? Uh, okay, yeah, I can answer this. So I'm noting your question. I'll answer this tomorrow, because it is going to, it is, yeah, deployment. For that I'll have to configure this thing, a cloud. So that also I'll try to include tomorrow. Okay, deployment I'll try to show you in some free cloud. I can show you that. Okay, so in
Sir,
some cloud environment. Okay,
sir,
and
can you able to hear me, sir?
sorry, I'm sorry. Yeah.
Sir, actually, neurofuzzy optimization techniques can be used here, sir, for any optimization techniques using artificial intelligence.
Yes, yes, yes. So we have that, like, we have that part for tomorrow. I'll be showing that
Okay, okay.
optimizations. Yeah, I'll be showing that.
Which is
And
the recent optimization techniques, sir? Neurofuzzy is the recent optimization techniques which is used, right, sir?
yes, yes, yeah. So in the field of AI, yes, that is yes, that is there. Like you might have, I had given, I think, example of Neuralink is one company. They also have been experimenting. So yeah, I will see if I can include that one. Okay, but I will show some optimization techniques.
Yeah, sir. Sure, sir. I'm working on that. That's what. If you are giving some information related to that, it will be helpful for me. That's what.
Okay, sure, sure. Yes, yes.
Thank you so much, sir. Thank you so much.
Yeah, pleasure. Okay. Regarding data sets, yes, as I have displayed here, that many data sets are available uh, here for practice purpose. So data sets dot, yeah, if you see, so Boston, breast cancer, diabetes, so many data sets are available here. Okay. Otherwise, always UCI machine learning repository is a good one. Kaggle is a good one. Okay, so and certain government websites which provide data related to like geographies and weather or population. So they are also providing for free of cost for research purpose. Okay, so one option is for practice purpose. If you're beginning, you can directly use this one. Okay, this package I have used from sklearn, import data sets. So from this you will get. Otherwise, free websites are there. You can use pandas library to work with the data set. So they are very good to work with data sets, pandas libraries. And yes, so I have, let me just make a note of these things. So I'll try to include them tomorrow. Here is my notepad, and yes, yes. So yes, we have, yeah, choosing the best algorithm. So deployment, I'll see, maybe if possible. So I have Azure account. I think it is still live, so I'll just check. So on Azure or on AWS, either of them, I'll try to show you the deployment. So AWS or Azure, and if not, then any free cloud. Okay, so any free cloud platform, I'll show the deployment part. And then yes, so you can cross validation techniques. Okay, so all this is a part of machine learning. I can show that. Yes, cross validation. So let me just And you can share your whatever inputs are required to the coordinators so that they can pass it to me. I'll try to include as much as possible. So yes, cross validation. I can show you that as well. Yes. Hmm. Okay. Okay. How to use more than one algorithm in ML? Okay. Yeah. So yes, that also. So normally we use ensemble models for that purpose. So use more than one algorithm. So one is parallelly you can use and test, and another is using ensemble. Okay. So parallelly use and compare. So I can demonstrate that. And otherwise better is to use ensemble. Okay, so that you will get only single result. So ensemble models are there that we can use. So I can help you with ensembles also, ensemble models for that purpose. Okay, feature extraction, fine. Yes, feature extraction, fine. Okay, yeah, so yes, I can include that. So okay, yes. So yeah, if there are more inputs, please send it through. Yeah, here also I'm noting it down. Otherwise, you can send it through the coordinators. I will surely try to include. And if something is missing, I will just add it into the classroom. Okay, if I'm not able to do it immediately, I'll just add it into the classroom so that the resources, either as a material, a video material, or a Jupyter notebook, I will put it. Okay, so yes, let's have a conceptual discussion because 15 minutes are there. So let me have a conceptual discussion for 15 minutes and then we will close for the day. Yes, tomorrow because it is about neural networks, which is more coming under the machine learning part. So I will try to include these things and we'll try to have CNN as well. Okay, with the help of Kera's library. Okay, so that I'll try to include. Okay. Hmm. So one of you said neuro FUZZY. I'll try to include that as well. Okay. So yes. Now going back here. Yes. So let's have a discussion on this part. I wanted to show you some more things. So let me just show you that. Then we can have discussion on this. Hmm. Okay. We can start with this. Then I'll move on to that. So yes, here we have propositional logic and FOL. Knowledge representation, we have been discussing that how the knowledge means now we are talking, and we are making use of different sentences. So how we can make this is basically natural language. Okay, so natural language is something which is very much complex for a system to understand, an NLP part. But for that also we have certain libraries, like we have bag of words. Okay, we have like I'll show you one library that is RDF, which basically identifies some semantics out of the whatever has been written as a text on different websites, or maybe as a natural language. Okay, so here let's discuss few things about propositional and predicate logic. So propositional logic is the first one. Propositional logic is defined as yes. So if we have a sentence like X is greater than Y, okay, or if we have Noam wrote this letter, so this sentence can be treated as one proposition, and this proposition can be either true or false. Okay, so a sentence can be treated as a proposition, and that sentence can be true or false. Now, we are discussing two things: propositional logic and first order predicate logic. So first order predicate logic can be simply called as FOL, or it can also be called as predicate logic. All are same thing. Okay, different ways we call them. So here you can see X is greater than Y and Noam wrote this letter. Okay, simple sentences. Now here we have certain uh, yes, so the same thing has been explained in this picture. You can see we have a logical constant. So anything can be true or false. So this sentence can be either true or false. Noam wrote his letter, wrote this letter can be true or false. Okay. Then we have symbols. Okay, P, Q, S. So symbols are like they are variables. Okay, you can call them as variables or symbols. They are atomic sentences. So this is important. Atomic sentences means you cannot have complex sentences. Complex sentences we'll see. Atomic sentences can be represented as the propositional symbols. Okay, and they are the propositions. Then we have parentheses, just to give priority for execution of one particular, if we have multiple propositions and we have some connectives, then basically which one to be given preference. Okay, so for that parentheses are there. Then we have connectives. Here we can see that we have and, we have or, we have implies, we have equivalent, we have not. Okay, so with the help of these we try to represent these sentences. Now we have again literals, atomic sentence, or negate atomic sentence. We have literals are immediate values. We'll see that how that is being shown here. So here you can see it is hot, we can represent it is hot as P. It is humid, we can represent it as Q. It is raining, we can represent it as R. Okay, so P simply means it is hot. Okay, Q means it is humid, and R means it is raining. So now using these, if I want to say it is humid and it is hot, so how can I write that? I can just write it as P and, okay, I can use this symbol conjunction P and I can write Q. So P and Q will mean it is hot and humid. Okay. Now here you can see in parenthesis we have written P implies Q. So P is it is hot, Q means it is humid. Okay, so this particular representation means if it is hot, okay, yeah, so P implies Q. So if it is hot and humid, then it is raining. Okay, so this sentence means this. If I just write this much, okay, if I just write this much, Q implies P, this means if it is humid, that implies it is hot. Okay, so if it is humid, then it is hot. Okay, and here this means if it is hot, then it is Q, then it is humid. But because it is in parenthesis, so this has already been done. Then if it is hot, then it is humid. So we can write it as if it is hot and humid, then it is raining, because we have put it in the parenthesis. So these are simple representation. Now, if I want to represent in the propositional logic that all triangles have three sides, now you can find the difference between it is hot and all triangles have three sides. So this becomes challenging for propositional logic to represent this in the form of propositions or these symbols P, Q, and R, because here triangles, sides, and there is a value 3. So all together, how can we put these three into a single propositional symbol? Okay, so it becomes difficult. So therefore, instead of using the propositional logic, we can move ahead and we can go to first order predicate logic. In first order predicate logic, how we actually write, we have a flexibility, we can have variables created. Okay, so if we want to write this, okay, we'll see that. So here, if I write gorilla is black, so in case of first order predicate logic, I can write it as gorilla, and in bracket I can write it as x. I can write black and I can write x, and go. So here gorillas, which are basically X, implies black X. So this means that if there is a gorilla, then basically the gorilla is black. Okay. If I have an attribute, or if I have not at, yeah, attribute, or we can say adjective. So John is tall. So this can be simply represented like this: John is tall. So with the help of parenthesis in first order predicate logic. Now here, continuation to that, we can have all boys like cricket. So in this case, what we can have is like, and in bracket we can have boys comma cricket. So first is related to second with the help of the kind of relationship we have mentioned here. So the first order predicate logic is also able to show the relationship as well. So boys like cricket. Now again, if we have some boys like cricket, so this is another a little complex situation, that this also can be represented like boys comma cricket. So that means boys like cricket. So in both the cases, if we see, we are not able to identify whether some boys like cricket or whether all the boys like cricket. So we are not able to identify that. So for this purpose, we need to have some more options of representing this. And the more options could be, they are called as quantifiers. We can have quantifiers which can help us with whether we are discussing about all, or we are discussing about few. Okay, so they can help us with that. So further moving, what we can have universal quantifier, which will be applicable for all, and we can have existential quantifier, which will be helping us with for representing some. Okay, so now the same example can be written like this. With the help of universal quantifier, we can represent this: all boys like cricket. And for this we are writing for all x. Okay, for all x, so this symbol is for all x such that boys implies like x comma cricket. So all boys are x and x like cricket, and here we have written for all. But if we have some boys, so we write for some x. Okay, so for some x such that there exists, okay, boys, and here we have written the relation x like cricket. So here we have mentioned that this is not for all, this is for some. So the propositional logic, okay, followed by the predicate or the first order logic. So propositional logic has got limitation, and propositional logic is followed by the predicate logic, which has got not only this but a lot of notations, and it help us to represent knowledge in this form. Fine, a sort of comparison. So propositional logic, it uses prepositions. Prepositions are basically these sentences. Okay, it is hot, so p is a preposition. Okay, and yes, in which complete sentence is denoted by a symbol. So it needs to be a simple sentence. But in case of FOL or the predicate logic, it uses predicates which can involve constants, variables, functions, and relations. So that means it can help us with complex sentence representation also. Then propositional logic cannot represent individual entities. For example, Mira is short, and it can represent this as well, like short in bracket Mira. Okay, so this way, this is how FOL is better again. And the propositional logic cannot express generalization, specialization, or pattern. Okay, but that can be very much done by the FOL. So here, how we can solve this problem: triangles have three sides, so we can have number of sides, and in bracket we can have triangle comma 3. So triangle number of sides, or we can have we can write it as, maybe instead of number of sides, we can write it as have sides. Okay, so it can be like this. So triangles have sides 3. Okay, so this is how the same sentence, without losing any value or any meaning, we are able to write. So triangle have or has sides 3. Okay, so yes, so this is a short example explanation of propositional logic and first order logic. Moving forward, I would like to show this also in the form of like how Python libraries are able to extract out the semantics from the written text. So that also I will include as a part of tomorrow's experiments. So that's it for today, and we can conclude here, and we can go ahead tomorrow at the same time. Yes. So any discussion or inputs are welcome, or else we can continue tomorrow.
Thank you, Kushal sir.
Yeah, thank you, sir. Pleasure.
If anyone have a question, please ask.
Sir, I have a question. Yes, Mr. Person. May I ask a question?
Yeah, is there a question?
Yes, sir. Sir, is
Yeah, yeah, please.
SQL is a library which is used for machine learning techniques?
Can you repeat, like the voice is very low. You said something about machine learning.
Is sklearn is a library which is used for machine learning techniques?
Yes, yes. sklearn is a library which contains machine learning algorithms, supervised, unsupervised, and even ensembles. And it has got a lot of optimization algorithms as well. It has got the this thing cross validation as well. It has got the metrics as well. So the complete set of machine learning with the help of a beginner can do with the help of sklearn.
And matplotlib is for the plotting a graph.
Yes, Matplotlib and Seaborn. So these are two libraries very much being used for plotting graphs.
Thank you so much, sir.
Yeah, pleasure, my pleasure.
I hope nobody have any question. Thank you, Kushal sir, for your such a great and wonderful session. Thank you, sir, and thank you to all participants for your patience listening. So here we have conclude the session. So we will connect tomorrow at the same time.
Okay, sir.
Thank you all.